Trigonometry practice test. Which of the following could be used to determine the measure of the largest angle in an acute triangle when all three sides are known? What's an acute angle triangle?
Angle less than 90.
Angles that are less than 90. Can I use SOHCAHTOA? When can you use SOHCAHTOA? What kind of a triangle do you need?
A right triangle?
Do I have a right triangle if it's acute angle?
No.
No. So can I use SOHCAHTOA? No, because it's not right. So SOHCAHTOA is right angles only. If I'm given the three side lengths, can I use Pythagoras' theorem to find an angle?
No.
No. Not to mention, what kind of a triangle do I need for Pythagoras?
Right triangle.
A right triangle. So I can't use the Pythagoras theorem. So now I'm between the sine law and the cosine law. If you look at your formula sheet that you were given, or that is in the book, in I think it's the front cover, back cover. Look at your sine law and look at your cosine law. Which of the two laws can you find an angle for? Can I find an angle with the sine law? So if I look at the sine law, it has sine A over A and sine B over B. So the A and the B, the capital, those are my angles. So could I find an angle with the sine law? Yes. But in order to find an angle with the sine law, I have to be given an angle. Was I given an angle in this question? So I can't use the sine law. The cosine law is written in two different forms. With the cosine law, I have that a squared equals b squared plus c squared minus 2bc cos a. And then I have the other one that is cos A equals b squared plus c squared minus a squared over 2bc. Does this find the angle? No. Given the three sides. So what is this question checking? It's checking your understanding of the formulas. More importantly, reaffirming or checking the fact that you cannot use Pythagoras' theorem and SOHCAHTOA for every triangle on the test, which is what some of you did the first time round. Not pointing names. Triangle RST has side lengths that are 5.5, 3.9, and 4.8. So you draw a triangle and label it RST. R to S is 5.5, R to T is 3.9, and S to T is 4.8, which means my triangle's not drawn to scale, is it?
No.
No, because 3.9 looks way longer than 5.5, and it shouldn't. So I could redraw my triangle if I wanted to make it look better. R to S was 5.5. R to T is 3.9. So then S to T is 4.8. It's a bit better. Question says the largest angle in the triangle to the nearest tenth of a degree is what? So how do I know which of these three angles is the largest?
Opposite of the hypotenuse.
But there is no hypotenuse. In order to have a hypotenuse, I have to have a 90-degree angle. And it doesn't say this is a right triangle. But in a right triangle, Dylan, because it does connect, the hypotenuse is the longest side. And which angle is it opposite from?
The hypotenuse. Oh.
The 90-degree. And what can you tell me about this angle compared to these two?
It's bigger than the others.
It's bigger. So if the bigger angle is opposite the bigger side, the same thing should work in this triangle. So which is the bigger side?
5.5.
And what's the angle opposite?
RTS.
That's the angle you're going to find. What formula do I use? And if you say SOHCAHTOA, I might throw something at you. Why can't I use SOHCAHTOA? It's not a right triangle. So now I'm between sine law and cosine law, and cosine law is the only one that you can use when you're given all three angles. That's what we have right up here. So the cosine of this angle, we'll call it T, is b squared plus c squared minus a squared. So the a squared is that 5.5. You notice these two match up. So T and the side opposite have to match up. So then I've got the 3.9 squared plus the 4.8 squared. And it doesn't matter if you put 3.9 squared plus 4.8 squared or 4.8 squared plus 3.9 squared. What matters is that you subtract the 5.5. And then this gets divided by 2BC. This is the B and the C. So when I go to put this into my calculator, I want to try to keep my answer as complete as possible. I want to use brackets. So bracket 3.9 squared plus 4.8 squared minus 5.5 squared, close the bracket, divided by the bottom. 2 times 3.9 times 4.8 equals, so I get this value here. So cos t equals all of that. Cos t equals 0.21 blah, 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 blah. I look at my answers, it's not one of the answers, because this isn't the angle. This is the relationship. This is what the cos t is of that angle. How do I find the angle itself? How do I go from a cos t to an angle t? Cos inverse. So I cos inverse the answer, which your calculator can do. Cos inverse, and then the answer I go second, and that negative button. So I get cos inverse answer 77.66. Which would be which?
C.
C. Question number 3.
I can't get that. I put my calculator twice.
Press the mode button on your calculator. What mode are you in? Okay.
I could read. Oh, I better press mode.
Oh, right here. On the bottom, when you went your 2 times, you have to put a second set of brackets. So second, insert, bracket. And then, because what your calculator will do is it's trained to do, or programmed to do, order of operations. So it takes this right here and divides it by 2, and then takes the answer and multiplies it by 3.9 and 4.8. If I want it to divide it by all of that, I need to put brackets on the outside of all of that. Okay? Okay. In triangle ABC, angle BAC is 60 degrees. Angle ABC is 72 degrees. And side length AC is 8 centimeters. Which of the following equations can be used to calculate the length of AB? That's this length right here. Okay? In order to use the cosine law, I have to be given the letter C. I have to have 2 sides in a contained angle, or all 3 sides. Do I have all 3 sides? C. No, I need at least two sides. In order to use cosine, you need at least two sides. I don't. So that means I'm in the sine law. So if I want to find out this side AB, using the sine law, I need the sine of angle C, so a side and its opposite, and a side and its opposite. So 8 over sine 72. Can I determine what angle C is?
Yeah.
How?
180 minus 60 and minus 72.
And what is 180 minus 60 and 72? Matt, where's your calculator?
I think it might be in my chem
48.
binder, I'm not sure, but it's still dead, so it don't matter.
In my chem law, sure.
So instead of writing sine C, I can now write sine 48. And what does that match with?
See?
C.
See what?
So then question 4 says calculate the length of this side. So you're using the same information. If I find the length of this side, to get AB by itself, I'm going to multiply both sides by sine 48. So sine 48 times 8 divided by sine 72. So when you go to put this into your calculator, watch your brackets. Open up a bracket, sine 48. And when you press the sine button, a bracket automatically opens. So I need to close the bracket. If I don't close the bracket and I go sine 48 times 8, it's going to go 48 times 8, which gives me 300 and something, 400 and something, and then take the sine of a 400-degree angle. That's not what I want it to do. Times 8, close the bracket, and then divide the answer by sine 72. And I get 6.2511. Which answer is that? A, B, or C? A. 6.3. Question number 5. Use the following diagram to answer the next two questions. Find the length of YZ, of this side. So can I use SOHCAHTOA?
No,
Why not?
not the right track.
Thank you. So I can't use SOHCAHTOA, which means I can't use Pythagoras' theorem, because Pythagoras is also a right triangle. So that leaves me with the sine law and the cosine law. In order to use the sine law, I have to have an angle and its opposite side. Do I have an angle and the opposite side?
No.
No. So if I can't use the sine law, that means I have to use the cosine law. So the cosine law, a squared, this would now be my a value. So a squared would equal b squared plus c squared minus 2b c cos a. So now, if I put that into the calculator, (39 squared plus 57 squared minus 2 times 39 times 57 times cos 19. I get 566.224 goes on. Does this seem like that's the right side length? What did I forget to do?
Square root it.
Square root it, because this is a squared. So then a would equal the square root of that answer, which would equal 23.79. So 23 23.79. Does that seem more reasonable? 19-degree angle is probably going to be smaller than these two angles, which means this side should be shorter than the other two. So which one would I circle, A, B, or C?
See,
C. Okay. Question number 6 asks for the area of the triangle. How do you calculate area? How do you calculate the area of a triangle? Base times height
divide by 2,
divided by 2. So what's the base of my triangle?
57.
Okay. What's the height of my triangle?
You gotta turn it into a right.
I need to make a height. There's the height of my triangle. How do I find the height of my triangle?
Pythagorean theorem. This is not a right triangle if you go to the left.
But is this from here to here 57?
No.
No, so can I use Pythagoras?
No.
But what can I use?
Your 19-degree angle.
So I have a 19-degree angle and I have what of my right triangle? Hypotenuse. So, and I'm trying to find, what's this side called? I could use sine, because it's the opposite, not the adjacent, right? So I have sine of a 19-degree angle is the opposite side, which is our height, over, was it 39? Yeah, 39, which is the hypotenuse. So the height of my triangle is 39 sine 19. So 39 sine 19 equals 12.697, and it goes on and on and on. So H equals 12.697, which I can now put into this formula. 57 times 12.697 divided by 2. So I can just add to this question. 12.697 times 57 divided by 2. 361.869.
8. 7.
Which would be
8.
8. Numerical response question number 1. An oil company drilling offshore has pipelines from platform Alpha and platform Beta to the same shore station that they call Delta. Platform Alpha is 180 kilometers on a bearing of 50 degrees from Delta, and platform Beta is 250 kilometers on a bearing of 125 degrees from Delta. Calculate the distance between platform Alpha and platform Beta to the nearest kilometer. So platform Alpha is 180 kilometers away from Delta. Platform Beta is 250 kilometers. And the question is, how far apart are these two platforms? So what I need is I need this angle measurement in here. Well, if from start to here is 50 degrees and start to here is 125 degrees, the difference between them is 75 degrees, which would be this angle measurement right here. So again, I can write the letter C, or I have a side angle side, so I can use my cosine law. So that would be finding length AB squared would be the two sides squared, 180 squared plus 250 squared, minus 2 times A times B cos 75, which gives me 71,606.29 I take the square root of that number, which gives me to the nearest whole kilometer 268. So in my numerical response box, I would start 2, then 6, then 8. Question number 6 says to use the says to use the following diagram to answer the next 3 questions. So we'll use this diagram for questions 7, 8, and 9. Question 7 says, what is the length of side MN to the nearest 1/10 of a centimeter? So if we look at MN, we're looking at this triangle from M to N to L to M. So again, this is not a right triangle, so SOHCAHTOA and Pythagoras' theorem are not usable. What I have is I have a side, angle, side. So I have an angle, I have 2 sides and its contained angle. I have that letter C formation, which means I can use the cosine law. So for this, I would have that MN squared would equal the 2 sides squared, so the sum of the 2 sides squared minus 2 times 64 times 51 cos 24 degrees. So I put that into the calculator and I get 733.375. To go from MN squared to MN, I would square root it. And when I take the square root, I get 27.1 centimeters. Question number 8 says, which of the following is closest to the measure of angle LMN? So LMN, that would be this angle right here. There are 2 ways that I could calculate angle LMN. I could use my cosine law. So the cosine law would be going cos M equals 64 squared plus 51 squared minus, I think I've got that wrong. 64 squared plus this 27.1 squared minus 51 squared divided by 2 times 64 times 27.1. That's so it looks like a 64. And when I put that into the calculator, I get 0.6427. And then I would take the cos inverse of that. So cos inverse of my 0.6427, which would give me 50 degrees. That's one way that I could do this question. The other way that I could do this question, if I go back up to this triangle, I could use MLP, which is a right triangle. Then I could use my SOHCAHTOA. I have a hypotenuse. Actually, no, I couldn't because I need 2 sides. So I guess that's the only way that I can do it. I was looking at the wrong question, sorry. The length of LP to the nearest centimeter is, so LP, that's this length here. So now I can use SOHCAHTOA because I have this angle being 50 degrees. So I could use my sine formula and opposite and hypotenuse. So sine 50 degrees equals the opposite side, which is LP, over the hypotenuse, which was 64. So then I multiply those together. 64 times sine 50 is 49 centimeters. Numerical response question number 2 is using the following figure, which is 2 triangles put together. So in question number 2, you're asked to find the side length of QS. So if I use this triangle, what I know in this triangle is I know 2 angles. And if I know 2 angles, I can find the third. 180 minus the 50 and minus the 71, which gives me 59 degrees. Now, in this picture, I don't have 2 sides in a contained angle, because the 2 sides here, I don't know what this angle is. And I don't have 2 sides within PQS, which means I can't use the cosine law. Can't use SOHCAHTOA or Pythagoras because I don't have a right triangle. So that leaves me with the sine law. So the sine law would say that length QS is to the sine of the opposite angle, which would be 59 degrees. And then in this one, I would use this pattern. So my 7.3 to sine 71. Something that I should know is that this side QS needs to be shorter than the 7.3 because 59 degrees is shorter than or smaller than the 71. To get QS by itself, I multiply by sine 59. So this is what I would enter into my calculator, and I would get 6.6 to the nearest 10. So in my boxes, the 6, the decimal, and the 6, and I would leave the last box blank. In numerical response question number 3, we're asked to find the measure of angle QSR. QSR, so that's this measurement right here. And I now know this measurement, 6.6. So I have 3 side lengths in this triangle, which means I'm using the cosine law to find the angle. So that would be cos S would equal, so it would be these 2 sides squared minus this side squared divided by the 2 of these 2 sides. So I'd have 4.8 squared plus 6.6 squared minus 5.2 squared all over 2 times 4.8 times 6.6. And that would give me 0.6244. So then angle S, I would have to cos inverse that ratio. And I get 51 degrees for my answer. And I don't need to put the degree symbol into my numerical response. For question number 10, the first hole at a golf course is 210 yards long in a direct line from the tee to the hole. So from the tee to the hole is 210 yards. Andrew Duffer hit his first shot at an angle of 15 degrees off the line. The angle between his first shot and his second shot is 105 degrees, and his second shot landed in the hole. So what is the length of his second shot? So what I have here is that this measurement here is 210 yards. So I have an angle and its opposite side. I have an angle and I need to find its opposite side. So that's again the sine law because I don't have the 2 sides in the contained angle. So I would have, I'm trying to find that second shot, so let's just call it S, would be to the sine of 15 degrees. As 210 is to sine 105. So when I'm doing these questions, I always put my unknown first and at the top. To get S by itself, I multiply both sides by sine 15. And when I put that into my calculator for an answer, I get 56 yards. now if we look at the next page, question number 11 and 12 deal with the same picture. In triangle PQR, angle QPR is 60 degrees, RP is 6 centimeters, and QP is 8 centimeters. And we're asked to find the length of QR. So if I look, I have a letter C. So I can use cosine law. QR squared would be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 60. So if I type that into my calculator, I get 52. And then I take the square root of that answer, and the square root of 52 is 7.2. So my answer ends up being C. The ratio sine Q to sine R to the nearest hundredth is what? So if I look at, to get to this point, I know that sine Q is to Q as sine R is to R. So if I cross multiply these, I get R times sine Q equals Q times sine R. And my goal is I want to get sine Q and sine R together, so I divide by sine R. And then I need to get this R gone. So sine Q over sine R equals Q over R. Q is 6, R is 8, and I get 0.75. Question number 13, triangle LMN is obtuse at M, and angle MLN is 40 degrees. What is sine LNM equal to? So it's an obtuse angle. So I'm going to draw an obtuse angle greater than 90 degrees triangle. LMN, because it's obtuse at M. Angle L is 40 degrees. Sine LNM, that's this angle here. So sine N is to the opposite side, which is side length LM, is to what? So if I look at my choices that are given to me, I've got this angle right here. So I would choose this side. So I'd have sine of my 40 degrees is to MN. I want this by itself because this is the same as LNM. So sine N would equal, I'd multiply by LM. So LM times sine 40 divided by side length MN, which is choice A. Okay, so let's look at question number 4. At 5 p.m., the distance between the tip of the minute hand on the clock and the tip of the hour hand is 17.4 centimeters. If the minute hand is 10 centimeters longer, the length of the hour hand to the nearest tenth of a centimeter is what? So I think of a clock. There's 12 noon, and there's 5 o'clock. This is my minute hand, so that's my 10 centimeter long. The distance between the tips of the two hands is 17.4 centimeters. And the question is, what is the length of the hour hand? What is that measurement? So what I can do is I need to try to figure out an angle. If I could figure out an angle, my life would be a lot easier. So what angle could I figure out? Well, I can figure this out. Okay? On a clock, goes around in a circle. So 360 degrees divided by 12 hours gives me a movement of 30 degrees per hour. And I moved 5 hours. That's 150 degrees. That's what goes right here. So in order to find this question out, I can't use the cosine law because the cosine law is an angle. It's either 3 sides or 2 sides in a contained angle, which I don't have. So I'm going to have to use the sine law. But I'm going to have to do 2 steps because the first thing that I'm going to need is I'm going to need to figure out, I've got one angle, I need the other angle. If I can find this one using my sine law, because I'll have this relationship, and then I can find this relationship, I can find this angle, use the sine law again, and I can find this side. So it's a little bit more involved of a process. So I have this angle here is what I'm going to try to find. So let's call this angle T. Actually, we'll call it H for hour. There we go. So angle H. So sine H is to 10 centimeters as sine 150 is to 17.4 centimeters. So to get H by itself, I multiply by 10. And then I get my ratio, which is 0.2874. Then I take my sine inverse to get H. And I get 16.70 degrees. I'm going to want to leave a couple of decimal points in my degrees because I don't want to round until the end. If this is 16.7 degrees, if I call this angle M for minute, I would go 180 minus the 150 minus the 16.7, which would give me 13.3 degrees. Now I can repeat the process. X is to sine 13.3 degrees as 17.4 is to sine 150. I'm going to use these 2 measurements because they were given to me as exact values, so I don't need to worry about the rounding. So then X would equal 17.4 times sine 13.3, all divided by sine 150, which would give me 8.0 centimeters. And that's what I put into the box. So if I look at question number 14, a pilot leaves an airport flying on a bearing of 165 degrees. He changes directions and flies for 80 kilometers on a bearing of 205 degrees. Changing direction again and flies back to the airport. How far is he or she from the airport when he makes a change in direction? So, this is the airport. If he flies on a bearing of 165 degrees, we start here, this is 0. 90 degrees, 180 degrees, so 165 is going to be right here. So he flies on a bearing of 165 degrees. Doesn't tell me how far, it just tells me that he flew. Then from here, I put another set of crosshairs because he's going to change direction again on a bearing of 205 degrees. So 90, 180, so 205 is going to bring me in this direction. And he flies like that for 80 kilometers. So this was 165 degrees. This is 205 degrees from here. Then he flies back to the airport. So the question is, how far is he from from the airport when he makes this second change. So can you figure out this side length? So how would I solve this? SOHCAHTOA, sine law, cosine law, or you can't? Well, I don't have a 90-degree triangle. Can't use the sine law. What I have right here is I have that if this is 180 degrees, this in here has to be 25 degrees. 180 minus, or 205 minus 180. Which means this angle in here would be 65 degrees. And then, what I have here, in this measurement right here, if this is 90 degrees and the whole thing was 165, 165 minus 90 would give me 75 degrees. And right here, I have an alternate angle. Alternate interior angles, because these two lines are parallel and this is my transversal. So if this is 75 degrees, this would have to be 75 degrees. So I now would be able to calculate this angle in here. So I have an angle, I need to find its opposite side. I could possibly use the sine law if I knew what this angle was. I don't. So I can't use the sine law. I don't have enough information. In order to use the cosine law, I need either all three sides, which I don't have, or I need two sides in a contained angle. I don't have two sides. I have a side, an angle, but I don't know this side because it didn't tell me how long it flew when it left the airport. Means the problem cannot be solved without further information. Question number 15 reads, Mr. Post's 2-meter-high fence has almost been blown down by the wind. As a temporary measure, he wants to tie a rope from the top of the fence to a peg 1 meter from the base of the fence. The fence is moved so that it's leading 25 degrees to the vertical as shown. Determine to the nearest tenth of a meter the minimum length of rope required if he allows 50 centimeters for knots. So in this question, what I have is I have this measurement here as being 1 meter. I have this angle here as being 25 degrees. I also know that the fence is 2 meters high. So I can put in a measurement here of 2 meters. The other thing that I can determine is I can actually determine what this angle is in here. Because from the vertical to the horizontal is going to be 90 degrees, and then I have another 25, so I have 115 degrees. So now if I want to determine the length of the rope, I would use the cosine law. SOHCAHTOA is out of the question because I don't have a right triangle. Sine law I can't use because I don't have an opposite angle and its side. So cosine law is what's left. So to find the length of the rope, which I can call r squared, that would be 1 squared plus 2 squared minus 2 times 1 times 2 times cos 115. This gives me 6.690, and the square root of that ends up being 2.587, and that's meters. And then I need to allow 50 centimeters for knots. 50 centimeters is half a meter, so that would be another 0.5 meters. So I get 3.087 or 3.1 meters to the nearest tenth. So my answer would be D. I have to be careful because if you look on this question, C is also a plausible answer, which was the 2.6. So I need to make sure I go back and I read the question and make sure I've answered the question completely. Numerical response question number 5 reads, on June 30th, 1956, the world's largest freestanding totem pole was erected in Beacon Hill Park in Victoria. Recently, a surveyor took measurements to verify the height of the totem pole. In the diagram, triangle ABC lies in a vertical plane and triangle BCD lies in a horizontal plane. What that means is this triangle was drawn on the ground and this triangle is the height of the totem pole a distance horizontally from it, and then my angle of elevation to the top of the totem pole. So if I want to find out what the height of the totem pole is, I would be best served by finding out what this length here is, because it's the shared length on both triangles. So if I look at this question, again, I eliminate the SOHCAHTOA in triangle BCD because it is not a right triangle, which leaves me with either the cosine law or the sine law. Cosine law I can use if I have 3 sides, which I don't have, or 2 sides in the contained angle. Again, I don't even have 2 sides. So now that leaves me with the sine law. The sine law says I need to have an angle in its opposite side. This is the side, which means I need to find out what that angle is, which I can do because I know what the other 2 are. So to find out that angle, it would be 180 degrees minus the 61 and 42, which would give me 77 degrees. Yes. So now if I'm trying to find side length BC is to its opposite angle, so BC is to 61 degrees, so sine 61, as 27.2 meters is to sine 77 degrees, which is this length in here. So to get BC by itself, I multiply by sine 61, so I'll get 27.2 times sine 61 over sine 77, which for an answer gives me 24.415 meters. Then I can use this side length BC in this triangle, which is a right triangle. So now I can use my SOHCAHTOA. I have an angle, I'm looking for its opposite side, and I have its adjacent, which is the tan ratio. So tan 58 equals the height of the totem pole divided by that adjacent side, which is 4.15. So then H would be that 24.415 times tan 58 degrees, which gives me 39 meters. Okay? The final question is a written response question. Use the following information to answer the next 3 questions. PC is a chord of a circle with a center of C and a radius of 8 centimeters, which means the distance from C to P is 8, and this distance in here is also 8. Not from the edge of the circle to R, just from C to the edge of the circle. Angle CPQ is 35 degrees, and chord PQ is extended to the point R such that C to R is 12 centimeters. So I don't even need that anymore. I can put in that this is 12. So the first bullet says determine the measure of angle CRP to the nearest tenth of a degree. So again, I go through my checklist. Not a right triangle, SOHCAHTOA, Pythagoras theorem, off the table. Then I've got cos law and sine law. It's always best to start off with the cosine law because there's only 2 conditions. In order to use the cosine law, I have to have either all 3 sides, which I don't have, so I can't use the cosine law, or I need 2 sides in the contained angle. I do have 2 sides, but I'm missing this contained angle. So cosine law is off the table, which means I revert to the sine law. So the sine law means that if I'm finding angle R, this time I put sine R on the top. Remember what I said before? We put our unknown on the top of my proportion. So sine R is to its opposite side 8, as sine 35 is to its opposite side of 12. And then to get sine R by itself, I would multiply both sides by 8. So I go 8 times sine 35, divide that answer by 12, and I get that sine R equals 0.3824. So to get R by itself, I I take the sine inverse of that ratio, and I get that R is 22.5 degrees. The second bullet says determine to the nearest tenth of a centimeter the length from P to R. So I can do this. I've got that this measurement here is 22.5 degrees, which means I can find out what angle C is. Angle C would be 180 minus the 35 and the 22.5 that I just calculated, which gives me 122.5. At this point, because I have all three angles, and I also have the two sides, I could use either the cosine law to find PR, so PR squared would be 8 squared plus 12 squared minus 2 times 8 times 12 times cos 122.5, or I could still use the sine law. So I could still set up and find the sine R to find the length of PR. PR is to sine 122.5 degrees, as 12 is to sine 35. So this ends up being the flip of the proportion from the last question, where my sine was on the top, this time sine ratio is on the bottom. And that is the nice thing with the sine ratio, is because it's a proportion, I can invert or flip them around and reciprocate them. I just make sure that I flip both sides. To get PR by itself, I would multiply by sine 122.5. So on my calculator, it would be 12 times sine 122.5 divided by sine 35, and I would get that PR equals 17.6 centimeters. And finally, the last part is determine to the nearest tenth of a centimeter the length of the chord from P to Q. So that's this measurement right here, from P to Q. So if I take my circle, my center of C, it goes out to P and it goes out to Q. I know that my angle measurement at P is still 35 degrees. I have that this measurement is 8. I also have that this measurement is 8 because it's an isosceles triangle. Or sorry, because these are both radiuses of the circle. These two measurements have to be 8, which means this has to be an isosceles triangle. If it's an isosceles triangle, this angle here has to be 35 degrees, which then means 180 minus the two 35s makes this angle measurement here 110 degrees. So again, I could use either the cosine law or the sine law to find PQ. I'm going to use the sine law. PQ is to sine 110, as 8 is to sine 35. So to get PQ by itself, 8 times sine 110 degrees divided by sine 35, and I get 13.1 centimeters. So the key when you are preparing for this trig test is knowing which of those 3 rules or 4 formulas that you can use. When do you use SOHCAHTOA? Has to be a right triangle. When can you use Pythagoras' theorem? Has to be a right triangle. Sine law and cosine law, we always pick the cosine law first because there's 2 situations that I can find it out. I either am looking for an angle given all 3 side measurements, or I'm looking for a side when I'm given 2 other sides and the contained angle. To use the sine law, I need to have an angle and its opposite side. So that's the condition behind the sine law. I need an angle and its opposite side. If I do not have that, I cannot use the sine law. So when you're going through these questions, read them carefully. If there is no triangle diagram drawn for you, sketch one out so that you can visualize and that you know what it is that you're trying to calculate.